Hey guys, this is the AC Service Tech, and today what we're looking at is an electric resistance heater that was taken out of a space pack unit. All right, so this unit, all right, the actual whole system did have the correct charge when I checked the charge, but I did check the filter. I noticed right when I went into the building and I went around to all the supply registers that it really wasn't blowing as much air as it should for being a high velocity system. It's one of those systems where you have 2-inch supplies coming down in the corners of the rooms, and it really was not um, pushing very much air. So I looked upstairs in the attic, and once again I checked the charge, and it was 18 to 21 degree temp difference, and we had the proper subcooling on the unit, but it was not pushing the air. It had a PSE blower motor. The problem with it is this electric resistance basically have a 9-inch supply going on with a space pack unit, and this brought it down to a 7-inch from here to here, and then you had all of this electric resistance. If you actually can tell from here all the way to here, that's about 20 inches. So 20 inches worth of electric resistance in this thing. I would never recommend using electric resistance with a high velocity system. Number one, the duct is a little small. Number two, it's just not doesn't feel comfortable in the middle of winter, right? You know, you have high velocity air moving. Any type of air movement in the wintertime does not feel right because of just evaporation on your skin. Makes you feel cold, even if it is hot air. The house had a boiler as well, so that was actually providing the heat. So this part of the electric resistance right here, which is actually a duct, it's actually about 2 foot long from flange to flange on the other side. We end up removing uh, this piece of ductwork with all the electric resistance heaters in it. It actually has 1, 2, 3, 4, 5 sections to it. And once this was removed, we put the correct supply size duct in, and then the PSE blower motor was able to push the correct amount of air through the duct system, and actually was about double the amount of air. And the refrigerant charge that it was charged with now did not have the right subcooling, and a little bit more refrigerant needed to be added. So now you have a higher velocity air at the evaporator coil, which then you needed a little bit more refrigerant to absorb the energy right there from the building. And after that was done, the house was able to reach its set point within the correct amount of time, and everything was good. So the whole point of telling you this is to look for duct restrictions, whether the duct is collapsed, whether something was designed wrong from the get-go, which this right here was designed wrong. That house has been there for about 15 years with this system in it, all right, for air conditioning. Never really cooled right. So this is my first time going out there, but this was actually the problem. So just because you have the correct charge and you have air blowing out of the ductwork and the filter's clean does not mean that it is actually cooling properly. All right, so this was the issue right here. Now I'm going to go ahead and show you the inside of this just to show you what it looks like. So that's not going to push a whole lot of air through the house when you have that much of a restriction. There's coil after coil after coil after coil of wiring going through this whole thing. All right. You can see all of it. It's 20 inches worth of electric resistance coils. All right. So if you did need to use the space pack, you know, you're going to have to use that for air conditioning and come up with something else for heat. All right. But that's that. I just wanted to show you that. And hope you enjoyed yourself, and we'll see you next time at AEC Service Tech channel.